Let us learn JVM architecture in detail. I have already explained you the components of JVM. Now let us look at them in detail. See, the first thing here is class loader. This is a class loader. Class loader is having three sections. One is loading part, and next is linking part, and then initialization. Three things are there. So it does three things. First of all, it will load the classes. Like I said, the classes must be loaded in method area. And one more thing I will tell you here, listen carefully, the very important thing, whichever class is loaded, its object will also be created inside heap area. Its object will be created inside heap area, right? So that it supports reflection API. Okay, you will be learning about reflection API. So it supports reflection API. So a class object will be created here and the methods will be loaded here. So loading has three parts again. There are three types of loaders. One is bootstrap loader, and extension class loader, and application class loader. I will explain these. See, application class loader will load those classes that belongs to our application. Means our own program when we write, and if we write our own classes, those will be loaded by this application class loader. Then bootstrap loader and extension class loader, these loaders will load the runtime classes that are required by JVM. See, all the library classes of Java, like Java Standard Edition, Java SE, all those classes, whichever class is required, will be loaded by this bootstrap loader. So this bootstrap loader is responsible for loading Java SE classes whichever are useful in our program. Then extension classes are useful for runtime environment, providing runtime environment by JVM, and these classes are loaded by extension class loader. If you want to see what classes are loaded by bootstrap loader, this one and this one, I will show you the path in JDK 1.8. See, this is a C drive, and inside this program files Java folder. See, there are two versions of Java installed here. The one I am using in this course is Java 13, and the latest version right now is 14, available now on the Java website, Oracle website. But the architecture that we are learning is based on Java 1.8. So for explanation, I have downloaded the folders of JDK to explain you what does bootstrap loader do and extension load class loader do. So this JRE folder, if I get inside this one, library folder, inside this you will find one file called rt.jar. This file. This rt.jar file will contain all Java SE classes, and this will be loaded by bootstrap loader. Then there is a folder called extension. If you get into this, there are some jar files containing the classes that are useful for JVM at runtime. So these are loaded by extension class loader. An application class loader will load our classes, whichever program that we want to run. Let us go back to the diagram. So this is about loading. Now next is linking. So this linking part is having three things: verify, prepare, and resolve. First one, verify. It will check whether the bytecode is a perfect Java bytecode or not. If there is any problem found or the pattern is different, then it will give verify error. So you can say that this will check that running the code is secure or not. If the code is not secure, it will not execute it. So it will verify the bytecode, is it in perfect form or not. This is verify. Then prepare. This one will allocate memory for static variables used in our classes. Static variable will not be stored in stack or heap area. They are kept inside method area. So just a loading process. This is done at the loading process. So a prepare will allocate memory for static variables that are used in our classes. Then lastly, resolve. As this is linking process, so actual process of linking is here. Suppose there is a method called fun1 in our class, and that is being called from main method fun1, we are calling it. Then listen carefully this point. Okay. See, at the place of method call, the address of this method must be stored or reference must be stored. So when it is possible, when these methods comes inside method area, then only the reference is possible. So main is calling so and so method. So main should know where that fun1 is present in the main memory, like in method area. So this is called as linking. Writing the reference of a method at the place of method call is called as linking. This is done by resolve. Then lastly, initialization. This will initialize static variables. All the static members of the classes, it will initialize them. Means it will keep the given values, assign the given values to them. And it will also execute static blocks. So you have learned about the static blocks, it will execute them. So it means the static blocks are executed at which time? Loading time. It is done by class loader, and the part of class loader which does that job is called as initialization. So class loading has three things to do, and again they have sub processes inside or sub steps inside. So this is having multiple small tasks inside. Just we saw this as class loader. Now we are learning in detail about this one. So once again, loading of various classes is done by loader. So we have seen different type of classes. Then linking is done finally here, but before linking, verification is also done whether the code is perfect or secure to execute or not. And meanwhile, the variables are also, static variables also allocated. Then they are initialized, then the static blocks are executed. So these are the steps done at class loading time. Method area we know well, heap area I have already explained you in the previous videos. Then if you see stack, we have learned about multi-threading in Java, right? Multi-threading. So there are more than one threads running inside a program. Suppose multiple threads are running, then each thread will have a separate stack. So three different stacks are maintained if there are three threads. But all those threads will use the same heap area, but each thread will have its own stack area. Separate stack will be maintained. Then if there are multiple threads, then there should be multiple PC registers. For each thread, a separate PC register will be there. So that's it. These are the details we have learned, right? Now this is native method stack. I have already explained in the previous video, in the beginning videos. The next is execution engine. It is having a interpreter and JIT compiler. Interpreter will convert bytecode into machine code line by line and execute it. And if that code is executing again it will convert into machine code. So each time the code is converted. But whereas if JIT compiler is used, then machine code is generated only once and it is repeatedly executed. So if there is any repeating code, then JIT compiler is used. Then next thing is garbage collector. If a program is creating an object inside heap and if it is not using it after some time, then garbage collector will take away that object. We have already learned about this one. So this is a part of execution engine. Then lastly, native method interface is there. So that will help Java programs or JVM to interact with native methods, and this is the library of native methods. So these are the few details that we have learned. This internal details of class loader and the stack, that is separate stack for each thread we have learned. So this was the important part that we have discussed, and then execution engine. The rest of the things are same what we have discussed in the beginning. So that's all. This was the architecture of JVM. All right. So I have given the details of this one. So this is sufficient. So if you just watch it for more than one time, then you may be remembering the things. So this may help you in interviews. If they ask any questions related to JVM architecture, you can answer these things. So that's all in this video.